Welcome back to Advent of Code. I'm now on to 2017 out of these years. So I've got 18, 19, and 21 to do before December somehow. Oh, I need to turn that light off and get my coffee too. All right, so before I do anything, let's just open up the... So as always, we have 25 problems to do. Let's start with problem 1. All right, let me just get some stuff. Okay, what have we got here? Day 1, inverse capture. Twas the night before Christmas. One of Santa's elves calls you in a panic. The printer's broken. We can't print the naughty or nice list. By the time you make it to sub-basement 17, there are only a few minutes until midnight. We have a big problem, she says. There must be almost 50 bugs in this system, but nothing else can print the list. Stand in this square. Quick. 50? Okay. There's no time to explain. If you can convince them to pay you in stars, you'll be able to... She pulls the lever and the world goes blurry. When your eyes can focus again, everything seems a lot more pixelated than before. Are we in Minecraft now? She must have sent you inside the computer. You check the system clock. 25 milliseconds until midnight. With that much time, you should be able to collect all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each millisecond in the Advent calendar. The second puzzle is unlocked when you complete the first. Yeah, same rules as always. Alright, you're standing in a room with digitization quarantine written in LEDs along one wall. The only door is locked, but it includes a small interface. Restricted area. Strictly no digitized users allowed. Goes on to explain that you may only leave by solving a captcha to prove you're not a human. Apparently you only get 1 millisecond to solve the captcha. Too fast for a normal human, but it feels like hours to you. The captcha requires you to review a sequence of digits and find the sum of all digits that match the next digit in the list. I don't understand from that sentence alone. Right, the list is circular, so the digit after the last digit is the first digit in the list, okay? Find the sum of all digits that match the next digit in the list. What? Alright, the example. 1122 produces a sum of 3. Because the first digit, 1, matches the second digit, and the third digit matches the fourth digit. Oh! Yeah, that wasn't very well worded, to be honest. Sum of all digits that match the next digit in the list. How would I have worded it? I don't know, like... Match the sum of all digits D such that d equals d plus 1. Like, be more mathematical, then it's more clear. All right. Sorry, not d plus 1. Sum of all digits. There's a better way to word it, I'm sure. Such that the dth digit matches the d plus 1th digit. Okay. For example, okay, so 1111 would be 4 because each digit matches its next one. 1, 2, 3, 4 produces 0 because no digit matches the next. 9, 1, 2, 1, 2, 1, 2, 9. Because the only okay, I get it. All right. So this is our input. We only get one number. Okay. All right, so all right, so how do we begin? With open input. It is a text file, right? Does it have an extension? It's text, right? Is it? Read only. Okay. S equals f dot read line. Strip off the new line characters. Okay. So we want a total equals 0. Okay. For I in range. Let's say for I x in enumerate s, we want to check that x equals the I plus 1th. So we want to say if x is the same as s I plus 1, but we want to make this circular, so we want to modulo s total plus equal int x, and then print total. All right, with open I forget how to use the open command. Oh yeah, of course. The as f goes out here. Input. It's just called input. It doesn't have a file extension. 1089. All right. Correct. Part 2. You notice a progress bar that jumps to 50% completion. Apparently the door isn't yet satisfied, but it did emit a star as encouragement. The instructions change. Now, instead of considering the next digit, it wants you to consider the digit halfway around the circular list. That is, if your list contains 10 items, only a digit in your sum if the digit 10 over 2 equals 5 steps forward matches it. Okay, easy. We just changed the that was part 1. Let's make this, that's n equals length of s. So part 1. Hello, Gaffer. wgaffer. Have you done any advent of code before? So I want to use n there now. And now we just want to completely duplicate this, but use... I've done a few. Nice. Have you done 2017? So I guess this one we just want just n over 2. No. We want to add n over 2. Modulo n. Alright, try that. So let's move that down a bit. 1156. Okay, that was a nice easy warm-up. I think I've only done 22 and 23. 23 will be this year. I guess you mean 21 and 22? I mean, yeah, they do get harder. I think they have, and the recent years have been harder than the earlier years. 2015 and 16 I felt were much easier, especially 2016, which I did a couple of months back. It was mostly just lots of breadth first search problems, to be honest. But yeah, I did 22 live and 20 live, and 22 was pretty tough in places. Was that the one where you had the cube and you have a you have to work out where you end up on the faces of a cube? That was pretty tough. Mostly because of the tediousness of working out how the edges of the cube connect. It wasn't theoretically tough, though. There were a couple of problems that were more theoretically tough that year. I can't remember which ones. Maybe. Oh, this one might have been. Where you have the elephant and you're running around opening valves. Because you had to run a simulation. Alright, well, we're on 2. Corruption checksum. Might as well update the stream to day 2. (22, 8, 12). 22, 8, 12 stars on years 22, 21, 20 is what I have currently. So 22, 8, 12. I don't even know what 21 was like. I forgot to do it that year. So yeah, I'm trying to do them all before this December. I don't think I'll manage because, you know, I'm busy doing other stuff as well, like streaming games, but probably can squeeze them all in. So you started in year 20. That's when I started as well, yeah. Yeah, it's a good site. I always recommend it to people now who want to learn coding or practice coding and stuff. A lot of the good sites have shut down. Google Code Jam is finished this year. They had been going for over a decade. Competitive programming is just kind of falling out of favor these days. It doesn't seem to be as popular a sport as it was. But there is this one, which I really like, codinggame.com. This one is more focused on AI, so you're programming bots that play games. But this is what I started streaming because it's also pretty good. Very different to Advent of Code, but it's more pathfinding and AI focused. But it's still entry level because people can start with the most basic AIs and build on that. Or you do coding game as well, nice. Yeah, now these are my two top picks. Like I used to do like Code Jam and HackerRank and stuff, but those aren't as fun, or at least they're not good for streaming. They're more good for quietly solving on your own, to be honest. Alright, corruption checksum. As you walk through the door, a glowing humanoid shape yells in your direction. You there! Your state appears to be idle. Come help us repair the corruption in this spreadsheet. If we take another millisecond, we'll have to display an hourglass cursor. The spreadsheet consists of rows of apparently random numbers. To make sure the recovery process is on the right track, they need you to calculate the spreadsheet's checksum. Oh, I forgot. I'm supposed to have ChatGPT solve it as well, see if it solves it faster than I do, which it normally does. How do I do this again? So we say, these are all my past ChatGPT conversations where it's solving problems. I'm sure ChatGPT will manage this one easily. Pretty much what I did. Except it wrote the code in a much cleaner way and it made it functional. Alright, so we want make a new file for this. One ChatGPT. Run one, so it's 1089 and 1156. Ah, wait. It's called input, not input.txt. I'll let him off because I told him the wrong thing. 1089, yeah. All right, now we just give him problem 2. Oh, yeah, that's fine. Now adjust for this. All right, looks good. Oh, I gotta tell him it's called input, not input.txt. 1156. Yeah, of course he does it. Of course he manages. Hang on, I don't have the. So this was last time. So this was 2016. There were 16 instances where ChatGPT beat me. Many cases he needed a bit of prompting because he got a wrong answer on the first couple of attempts, but I was like, doesn't quite work, can you fix it? And he did fix it, so. And there were 9 occasions where it couldn't solve the problem. But, I mean, if he solves it, he always solves it faster than me, so that's a win for ChatGPT, so we have to reset this. So, we're on 0, he's on 1. All right. Day 2. Alright, so the spreadsheet consists of rows of apparently random numbers. We need to calculate the checksum. For each row, determine the difference between the largest value and the smallest value. The checksum is the sum of all those differences. That sounds easy. That sounds even clearer than the first day. Okay. Alright, so we want 2. Whoops, wrong one. Okay. Right, so these are tabs? Yeah, okay. Alright, so I guess we just want to copy this roughly. For line in f.readLine. Okay, so we've got L equals int x for x in line dot split. Okay. So we have a total equals 0. So total plus equal, so it's going to be the max number minus the min. These are all positive numbers. Four 4216. Correct. All right, that was easy. Part 2. Great work. Looks like we're on the right track after all. Here's a star for your effort. However, the program seems a little worried. Can programs be worried? Based on what we're seeing, it looks like all the user wanted is some information about the evenly divisible values in the spreadsheet. Unfortunately, none of us are equipped for that kind of calculation. Most of us specialize in bitwise operations. It sounds like the goal is to find the only 2 numbers in each row, where one evenly divides the other. That is, where the result of the division operation is a whole number. They would like you to find those numbers on each line, divide them, and add up each line's result. So find 2 numbers where one divides the other, do the division. Okay, fine. Yeah, sure. So I guess we could sort just to make this easier. So it's always left divided by right. Or right divided by left. Let's just do this in one go. Okay, so that's part one, and then the next bit we want is hang on. Okay, so we want L.sort, so it's now smallest to biggest, and then we want for X in so they're not going to be equal, are they? Otherwise, let's have a look at it. 8 and 2, 9 and 3. I think they're never going to be equal yet. Okay, so okay, just do it really quickly then. So for X in L or Y in L, if X is not equal to Y and I don't know, Y percent X is equal to 0, then we want total 2 plus equal Y divide out the evenly divisible result. Okay. We can also break out of the loop just to save time. 2860. Too high. Damn it. Oh, because I get it. Yeah, because that break is not good enough. Hang on. It's still doing. We want. Just say. What's a clean way to do this? Just done equals false. If done break. Probably the better way to do this will be to make an inline function. Then we can just do a return here. Done equals true break. Okay, do that. 20. No, it's the same answer. What? 2860. Sorting also is irrelevant, but alright. We need to print what's going on here. 44216. Ah, why did I divide y by 2? What the heck? Divide by x. Alright, there we go. 320. It's much smaller, but that makes sense because you're dividing. Okay. $320. What? Yeah, it was, yeah. Correct. Alright, we need to solve it with ChatGPT. He'll have no trouble. Alright, just copy this, but make sure we say input, not input.txt. The file is called input. Will he understand that? I hope he doesn't still call it input.txt. Alright, so pretty concise. Four 4216, correct, and then I won't switch windows, we'll just quickly okay, so he's same again, he's delivering another program, it looks fine. So he's got this checksum. Yeah, if I not equal to j, and yeah, it's the same thing I did, but yeah, that's what I did. Yeah, 320. Very well. That's another win for ChatGPT. All right, we're on to 3. Spiral memory. You come across an experimental new kind of memory stored on an infinite two-dimensional grid. Each square on the grid is allocated in a spiral pattern starting at a location marked 1 and then counting up or spiraling outward. So 1, 2, 3, 4, 5, 6. Okay. Whilst this is very space efficient, requested data must be carried back to square 1 by programs that can only move up, down, left, or right. Okay. How many steps are required to carry the data from the square identified in your puzzle input all the way to the access port? So we're trying to find where 2, 7, 7, 6, 7, 8 is on this grid. All right. Huh. Well, one thing we know is that the square numbers are going to be going down the bottom right diagonal. 1, 9, 25, and so on. Because it's a square. 2, 7, 7, 6, 8. 2, 7, 7, 6, 7, 8. We only have to count from the next square. What is the next square? Let's just... Square numbers. Give me the square numbers. Give them to me. Alright, so what are we looking for? 277678. So whatever's below that. 27. So it's 27556. So we're trying to find the Manhattan distance. Wait, so 27556 will be 166 by 166. But can we just solve this with pen and paper? So 166. So we would start in the bottom right corner. We would go. I need to at least be able to draw. Hang on, let's see if I can do this. Alright, let's get Paint open. I never thought of... Okay, let me... Okay, not that. That's the chat. There we go. So we've got, it's very bright. Can we, okay, draw in white. So we've got, why is it not working? Switch colors. Okay. All right, so we've got hundreds. All right, so 1 is there. All right, and then we've got 166 by 166. And then we've got this number here, which is 27557. Okay. What am I trying to do? Again, I forgot the whole problem. Find where 277678 is. 277. Let me just copy that in. 277678. Okay. So if we go up to 167, we would end up in this top corner here. 27557 plus 167 is 27724. 27724. Hang on, what? That number's too big. What have I done? 27556. Oh my god. I'm way off here. I'm a whole factor of 10 off. 277678. 277. We have to go further down. And I'm not showing the right window now. Two, 7, 7. Here we go. Oh, it's close. 277678. 277729. So it's actually really close. So this won't be hard to calculate. Can we... All right. Okay, start again. All right, so where were we? So we've got to find that 277729. What we have here is no, that's not what we're trying to find. Oh my god, I'm getting all the numbers mixed up. 277678. Two seven seven 678. Okay. And the number we have, I swear this is still faster than coding it. The number we have is 277729. Two 77729, and we have this is distance 527. Okay, so over here 277729. Oh my god. Minus. Two 77201. Right, over here we've got 277201. Alright, so where is 277678? Somewhere here. We just need to work out the coordinates, so the coordinates of this one are, assuming 1 is at 0, 0. Hang on. This is all wrong. Hang on, let me just take that out. That is not distance 527. Take that out. Just put in what we know. Can't even see the cursor. Okay. Okay, so the coordinates of this. So if 1 is at 0, 0 and 9. Oh my god. I've made another mistake. It's not 2 squared, 3 squared, 4 squared. It's 1 squared, 3 squared, 5 squared, 7 squared, because Okay, fine. It's every odd numbered squared. And we've got 5 to 7 squared here. 5 to 7 squared. So, so it should be 263, 263. Is that correct? Because 9 would be 3 is 3 squared. 3 would be 1, 1. Yeah, so you do that. So we go 263 across and 263 down, and we get to this. All right, so it's just a question of where is 277, 678 relative to this one. It's just to the left. So you do 277, 729, 277, 729, take away I hate Google Calculator. 277, 678. 277, 678. 51. So we just got 51 to the left. So it would be 2, 1, 2. 2, 1, 2. 263. So the Hamming distance will be that plus that. 212 plus 263. Better be, because this really obscure way of solving it. Now I kind of think I would have been faster just doing the code. $475. Correct. As a stress test on the system, because it's part 2, we're going to need code anyway, surely, so I probably should have coded it. As a stress test on the system, the programs here clear the grid and then store the value 1 in square 1. Then in the same allocation order as shown above, they store the sum of the values in all adjacent squares, including diagonals. So the first few squares values are chosen as follows. Square 1 starts with value 1. Yeah, I'm gonna have to code this. Square 2 has only one adjacent filled square, so it also stores 1. Square 3 has both of the above. Oh man. Yeah, now we've got neighbors. We need to. The first value written that is larger than your puzzle input. Yeah, we have to actually calculate this iteratively now because... Okay, cool. So we just say print 475. Alright, part 2. So we have a grid, so we want grid equals dictionary. We want a default dictionary, which defaults to 0. Puzzle input. Okay, so okay, grid equals default dict int first value written that is larger than your puzzle input. So hello, Arshama20. I'm new to CS and I find C++ concepts like pointers hard to understand. I keep on forgetting how to solve LeetCode problems that I already solved months ago. Should I quit data structures and just focus on front-end and development? Well, I mean, so why are you solving LeetCode problems? Is this for interviews? Because I definitely would not recommend C++ for interviews, to be honest. Partly because of pointers, and partly because it takes ages to answer questions using C++. I always use Python myself. It's so much faster to code in. And in an interview, speed is everything. Speed of coding, not speed of execution. Because execution is always going to be instant, so you only care about ease of coding and nothing else. So I would switch to Python if you're doing interviews. It doesn't if you're interviewing for a job, even if the job is C++, they normally let you interview in Python. That's from my experience. But if you're talking about academics, like university exams or something, that's a different story, but yeah, it depends what your goal is. But I mean, I find pointers hard to understand, so I just avoid them. No pointers in Python or Java. So we want grid 0, 0. Equals 1. So we put 1 in the center here. Get spiral. Let's just call it get spiral. Current. So let's say x, y equals 0, 0. That's where we're standing right now. The college professor told me that it's a must to learn C and C++ to get good understanding of memory management and LeetCode problems. To have a good problem-solving mindset. I mean, yeah, that's how it used to be back in the day, but I wouldn't really agree with that. Nowadays, automatic memory management is much better than it used to be. if you're working with really low-level coding, where you're working close to the operating system and you're working on heavily optimized code, you know, for certain purposes. For example, I don't know, trading in financial firms where you need to be trading at like speed of light, then yeah, I guess those applications, it is important to know that stuff, but you can find a lot of jobs where you don't. Like a lot of jobs, I don't know, and like, I don't know, I worked in for Amazon before. I worked in Java mainly. I didn't have to worry about memory management much. It was mostly just using libraries that were already provided and working with those. So I don't really agree with the professor's assertion there. It really depends on the job, and there's so many jobs nowadays where you wouldn't actually need to worry about low-level programming to that degree of depth. I mean, there are many jobs which just work in Python. I haven't worked in one. I normally used Java before, but and a problem-solving mindset, I don't really see the connection. Memory management and problem-solving are two different things, and they're both useful, but I don't... Maybe a professor means that you only need to have a basic understanding of memory management. Yeah, I mean, I say at the very least, you need to know sort of what's going on behind the scenes, even in Python, because you want to know when it's deconstructing things. I've had competitions, like coding game, where I've actually run into issues because when I stopped using a variable, which was like a massive matrix, the Python started auto-recycling it, but that auto-recycling took up too much time, and I was losing rounds because it was taking too much time, so I had to sort of force it to keep the stuff open. But I didn't need to know much there. It was just very basic understanding that there is a garbage collector. It sometimes collects things, it sometimes deconstructs things, and there are conditions at which it decides to do that. That's all I needed to know. So... And I mean, in interviews, you get asked, if you work with Java, they ask you how the life cycle works for variables, like how the, what's it called, like the grandfather cycle of when variables become old enough that they get recycled and all this stuff. But it's not hard. You don't need to know pointers for that. So I think I ran into Python GC issues on this last competition. Yeah, it comes up, and it comes up unexpectedly because Python programmers don't normally expect that to come up, but it can take like several hundred milliseconds to garbage collect, which can cause your program to fail under the pretty tight time limits that coding game give you. Which is one argument that people make, that Python users kind of get a bit shafted compared to C++ users in that competition, but there's no way around that. I mean, wherever you set the threshold, C++ users are always going to have the memory advantage. But I mean, going by what the professor has said, I don't really agree with what they've said, to be honest. It's like, I don't know what he means by you need to, because you don't even need to know CS if you're not getting a CS job. So it's really depends on what you're actually aiming for. If the professor were good at coding, they'd make a lot more money not being a professor. Yeah, that's the thing. Professors are terrible at coding. My PhD advisor, he typed code with his 2 index fingers, and he typed terrible code. Like, I had to do a lot of his coding for him because he just couldn't really code. Professors don't become professors to do coding. You don't really do coding in academics. You write papers, and you produce theoretical results, but you don't usually actually bother producing the actual code to go with them, because most journals and publications just want the paper. They don't want the code. Academics care about what can be done, but they don't care about actually doing those things. That's why PhDs are basically a branch of philosophy. Not that I'm saying that's a bad thing. I actually enjoyed looking into theoretical results in computer science. That was my specialization, especially in the field of algorithms. That's pretty much what algorithmists do. They prove that something can be done with an algorithm, but they don't actually do it. They just move on to the next algorithm once they've proved it. Because actually coding the algorithm takes a different skill set, and arguably a less difficult skill set than producing the theoretical results. Right, where was I? So I think we do a go right, then we do a go up, then we do a go left, then we do a go down, and then just repeat that. Yeah, because in my PhD, I was not getting any practice in coding. I had to code as a hobby on the side just to keep my skills up for interviews and stuff. No coding whatsoever. Everything was done on the whiteboard or on pen and paper. The only coding I did was LaTeX. Okay, so while true, we just do this endlessly until we see that we have gone above this number. Go right. So we do x plus equal 1. And then we say while there is nothing above us. So while grid x, y plus 1, while not grid x, y plus 1, x plus equal 1. So when this while loop breaks, we are standing, so we are ready to go up. To answer another of your questions, whether to quit data structures and focus on front end. I'm not a programmer by trade, though. But doing projects are a good way, but I think learning some data structures isn't bad either. Should you be able to implement the most efficient RB tree in a snap? No. Yeah, no one knows how to implement this most efficient RB tree in a snap. But maybe learn the basics and what they are. Yeah, I would have to ask what you mean. What was originally meant by quit data structures. Who was it that said that? R. Sharma. Because what are we talking about quitting? A course, an actual university course. Okay, so wait, when do we break out? I think we have to. What is the first value written that is larger than your puzzle input? Oh, so we have to check every single time. Okay, fine. maybe there's a cleaner way of doing this then. Instead of this is an infinite generator then. So we yield. Yield. We don't need to yield the coordinates, do we? Just the number. So I can't think of the cleanest way to do this. It's a lot of repetition. Fine, we'll just do it. Don't start at 0, start at 1. So start with go up. That's the cleaner way to do this. So we start to the right of 0. So now the invariant is maintained. We have something to the left of us. So we can now start with the while loop instead of that. Okay, so while not grid x minus 1 y. So while there's not while. No, it's a while there is a number to the left of us, we go up. And we calculate the next number. So the next number is going to be, we can make an inline function here, say define get num x, y, return this is getting more and more confusing. Okay, so this is a method which, given coordinates, spits out what number goes there. So it will be the sum of all the neighbors, all 8 neighbors. Let's have a look here. Yeah, okay. So for dx in -1, 0, 1, or dy in -1, 0, 1, total plus equal grid x plus dx, y plus dy. We want to skip 0, 0 though. Well, actually, we don't care because there won't be anything in that grid entry anyway. Let's just skip it though. If not dx dy equals 0, 0 total, that adds up the 8 possible neighbors. Okay, so that's a method to get us the next number, so we don't have to type that code over and over again, which I was about to do. All right, so grid x, y equals or just say populate grid, so we don't even need to provide it at coordinates. We just say populate the grid at x, y, and then we do that, and we say grid x, y equals total. So now we just say populate grid x, y. Just call that every time. So we go up, we do that. And then yield. Okay. Now do we literally just do that every time? Now when we're going left, so we're saying while there's something below us, we reduce x, do that. Then when we're going down, we say while there's something to the right of us, we reduce y. And then finally, while if we had some notion of direction, then we wouldn't have to copy and paste this 4 times. We could just do that, but whatever. You would just change direction and do it with that direction instead. While grid, while what's above me we increase x. So that's an infinite generator now. We should actually yield the starting values as well, just to be complete, even though we don't need them. Grid 0, 0. So start at 1, 0. Oh, well, we also need to do this. Equals 1. Yeah, whatever. And then there was probably some cleaner way of not having to do that, but hello, Maro. Back to advent of code. I solved part 1 using Paint, purely using Paint. First time I ever had to whip out Microsoft Paint. But yeah, I solved it entirely using Paint. That's cool. ChatGPT will probably still beat me though. Alright, so get spiral. That's a whole lot of code that might not work because I haven't tested it. Okay, now we actually write the loop. So we say for so what do we want again? We want the first number that is larger than the puzzle input. Okay. For x, let's say for z in get spiral, if z is greater than puzzle input, print z break. That's it. Let's run it and see how many errors we get. $279,138. That sounds plausible because it's bigger than the puzzle input and it's a bit bigger. I don't feel confident with my spiral though. Okay, it was correct. I mean, okay, looking at that now, it has a nice symmetry to it. So it wasn't actually that hard. It's just you just have to get these indices and everything correct. If you wanted to write that really cleanly, you would have a notion of direction. So you'd have a direction vector. So the direction vector would be, say, go up. The direction vector would be 0, 1. X equals 0, y equals 1. And you would just add that direction vector and you would check whether the anti-clockwise direction by multiplying by the matrix, whatever, cos 90, sine 90, I forget how this works, but you know, there's a way of doing it where you wouldn't have to have all these while loops. All right, let's see ChatGPT solve this then. Just checking a couple of things. Okay, so we want let's see ChatGPT use Microsoft Paint to solve the first problem. Ha, bet you can't do that. I wonder if he's going to do an infinite generator like I did. Actually, sorry, I need to change something. The puzzle input was not in a text file this time. Let me just try that again. The input is that. Now he'll just probably hard code the number, so completely different program structure here. Ooh, I like this. It looks cool. 475 steps. He's actually calculated it, but he might have... You can't tell whether he's actually calculated it or whether he's just copying, because some people have used this already on Advent of Code Problems, so he memorizes their answers. Because sometimes it gives you the answers for someone else's input, which doesn't match your input, but it matches their answer. You can tell he's just copying what he was given before sometimes. Alright, but that looks good. But my paint program was clearly better. Look at that. Ooh, what's this? 1001? That's not the answer. "27768 is the number he's used. 27768. He knows it should be 475, which is interesting because that it is probably a different number for someone else. Why did this give 1001? It's a very different program to the last program he gave me. Well, how is he? What is he? How is he? So he's calculating the final size of the square at the start. Okay, whatever. The only thing we're allowed to do, we're not allowed to debug it for him. The only thing we're allowed to do is tell him it's wrong. Tell him it's too high. There was a mistake in the calculation logic. Okay, okay. He thinks it will be 475. Okay, we'll see. We'll see. Still 1001. Did I copy it correctly? That's a very strange number. 5, 1001. Where would 1001 come from? This could be a failure. Alright, we'll try again. 314. It's weird, he's not getting it. This might be a fail. Alright, well, this is the last chance. It's so strange that he's determined it's 475. He knows it's 475. He can't produce code. Like he could just sneakily make his code hard code 475 without me noticing. But it's not giving 475. GPT can't do calculations or program. Well, I mean, I'm sure it could do basic calculations. This is small numbers, so I wouldn't be surprised if it can actually calculate. It's like 500 or so squared. But I don't know if he's doing that, or because he can't really be taking 475 from previous people because they would have different inputs to me. So my best guess is that he's calculating that, but he's producing the wrong code to go with it. Because I solved it by calculating it by hand, which I found easier than coding it, so that wouldn't surprise me that he took the same approach. Still 314. Wait, did I copy it correctly? Taking off 4, no. He couldn't produce the Python code this time, so we win. We win with our paint program. Yay! That was pretty good. Took me a while though. I was getting the numbers all wrong, but it was still faster than coding, I think. All right, we're on to day 4. It looks like this image is producing a breadboard of some sort. Yay, a nice short description. That's what I like to see. A new system policy has been put in place that requires all accounts to use a passphrase instead of simply a password. Oops, sorry, not showing the screen. A passphrase consists of a series of words separated by spaces. To ensure security, a valid passphrase must contain no duplicate words. For example, A, B, C, D, E is valid, so no duplicates. The system's full passphrase list is available as you're passing. How many phrases are valid? So we're literally just counting how many have duplicates. Easy. Easy, we just use a set. Python sets are really, really easy in Python. So counting how many don't have duplicates, okay. Okay, for line and f.read lines, let's say L equals line.split. We want a total. Total plus equal set. So we want length set L is the same as length of L. If that's true, then that means there can't be any duplicates, because set will discard the duplicates. .337. That was one of the shortest codes I've ever done for any advent of code problem. Correct. For added security, yet another system policy has been put in place. Now, a valid passphrase must contain no two words that are anagrams of each other. That is, passphrase is invalid if any word's letters can be rearranged to form any other word in the passphrase. So we turn each word into its sorted form, basically. Okay. That's also easy, but we just need to add a couple of lines. Part 2, similar. Or should we just say, no, just duplicate this code. So we say, so we take the line, so line dot, okay, so we want, so now we want to modify X, so we want to say, so let's think, unpack this. List X will turn the word into a list of characters. Sorted list X would generate those characters in sorted order. Join would join it back up as a string, so now we just get a bunch of words, and then it should just be that, right? Two, three, one. Correct. Easy. That was one of the quickest problems. All right, ChatGPT will manage though. Although, I mean, I solved it pretty quickly, so, but yeah, probably he'll still solve it quicker. So okay, so that. So we're looking for 337. Server is a bit slow, the ChatGPT server. Yeah, same as I did. That's more sensible, making an isValid passphrase method. File name equals input.text. Well, I told you what the name was. Don't put that .text on the end. It was called input, not input.text. whatever, we'll accept that. Three, 3, 7, yeah, easy. Okay. Problem 2. So we're looking for 2, 3, 1. It's using a counter. But how do you compare counters? Is there a built-in He's using counter, so he makes counters instead of sorting the words. That's fine, that's sensible. Ah, okay, he takes the items list, sorted, and turns it into a tuple. Tuple of integers. Okay, that's one way of doing it. I mean, that's the more technical way of doing it, I guess. It's getting right to the point of what you're actually trying to find. I like my method better, though. Sorting the word means you can compare two words to see if they're anagrams of each other. You just sort the letters and they'll be equal. I don't know. I think it's more elegant. Anyway, it's called input. 2, 3, 1. Yep, that's correct. Okay then. Well, yep, that's another ChatGPT win. We're on to 5. Okay. We update the stream. Alright, these problems have been pretty easy so far. A maze of twisty trampolines all alike. It's like it might be some sort of pathfinding? No, maybe not. An urgent interrupt arrives from the CPU. It's trapped in a maze of jump instructions. Oh, is this assembly code stuff? They did a lot of that in the last year, 2016. It's trapped in a maze of jump instructions, and they would like assistance from any programs with spare cycles to help find the exit. The message includes a list of the offsets for each jump. Jumps are relative. -1 moves to the previous instruction and 2 skips the next one. Sure. Start at the first instruction on the list. The goal is to follow the jumps until one leads outside the list. In addition, these instructions are a little strange. After each jump, the offset of that instruction increases by 1. So if you come across an offset of 3, you would move 3 forward, but change that 3 to a 4. Interesting. Okay, fine. How many steps does it take to reach the exit? What's defined about how is exit defined? By going off the list. All right. forward of the list or anywhere outside the list? Interesting. Okay. Okay. Not hard. Let's grab the input. So it's an integer on each line. Okay, so just say you just turn all those into ints. Just don't want that blank line. A lot of negatives there. Okay. Alright, so I equals 0. While I, so we want okay, we want steps equals 0. So while I is between those boundaries, we say jump equals array I. We increment array I, and then I add equal jump, and we increment the step, and then when we exit out that, we just print the step. Three 36905. Sounds quite big, but I mean, yeah, it could be. Just jumping back and forth a lot. That's quite big. Correct. Now the jumps are even stranger. After each jump, if the offset was 3 or more, instead decrease it by 1. Otherwise, increase it by 1 as before. Fine. How many steps does it now take? Okay, fine. Just a minor change. Have to just repeat all of this. All right, so if jump was greater or equal to 3, was that how it worked? 3 or more, decrease by 1, else array I plus equal 1. Okay. Ooh, could this be one of these ones that takes too long and you have to find some clever way to speed it up? Oh. It's a bit early for that. Big number though, okay. That was nice and easy. Let's say no extension. No file extension. Maybe it would have been easier if I just made it .text, but whatever. Okay, let's copy that in. Three 36905. Yeah. All right. Take a while again. Two 21985262. 219852. Yeah, correct. Okay. That was another easy problem. If I could get to 12 this stream, that would be halfway, basically. I don't think... I mean, they're going to get harder at some point. Alright, memory reallocation. A debugger program here is having an issue. It is trying to repair a memory reallocation routine, but it keeps getting stuck in an infinite loop. In this area, there are 16 memory banks. Each memory bank can hold any number of blocks. The goal of the reallocation routine is to balance the blocks between the memory banks. The reallocation routine operates in cycles. In each cycle, it finds the memory bank with the most blocks and redistributes those blocks among the banks. To do this, it removes all the blocks from the selected bank, moves to the next memory bank, and inserts one of the blocks. Interesting. Okay. The debugger would like to know how many redistributions can be done before a blocks in bank configuration is produced that has been seen before. I think I already know enough to start coding. Okay. We start with that. Is that tab separated? Yeah. All right. Doesn't seem hard. Just, it's a simulation. Just do it. Just do what they said. All right, so one. Okay, so let's say block, what are these called? Let's try and use the terminology. Banks. Banks equals f.readline dot split int x for x in. We could use map as well. Okay. Let's just do some logging. I don't really do that, do I? It'll help. Okay. So that's the banks. So what do we want to do? We want to while, okay, so we want to put we want to keep a table. Let's call it table equals set. Start off with tuple of banks. Okay. No, just make it an empty set. Okay, so we say while tuple banks is not already in the table. Keep doing this. We say oh, okay, at this point we put it in the table. We say table.add tuple banks. And then what? We take finds the memory bank with the most blocks. So I think you can just say I equals banks.index max banks. That should just find the first one. And then what do we do? Remove all of the blocks from the selected bank. So blocks equals banks I equals 0. Okay, while we have blocks in our hand, I equals I plus 1 wrapped around banks. Blocks, remove one block from our hand, put that block in the bank. Just do that until we're out of blocks. Yeah. So the moment it is in the table, we just print the length of the table. Like if we ended up, if the very first iteration gave us something we already had, we would have the first starting state in the table, but we would not add the next state. So we would have 1, and that would reflect the fact that we've performed block separation once. So yeah, 3, 1, 5, 6. Correct. Out of curiosity, the debugger would also like to know the size of the loop starting from a state that has already been seen. How many block redistribution cycles must be performed before that same state is seen again. So we continue on from solving part 1. That's interesting. We don't normally do it that way. So we are now on a state we've seen before. State equals tuple banks. So tuple banks is a duplicate of something we've seen before. And it's the first such duplicate. So now we'll just go in an infinite loop. Now what we could have done is record when it was that we put it in. Let's just carry on from here. So just say state equals tuple banks. Steps equals 0. While true. So we just do all of this again. Banks state equals tuple banks. Steps equal 1. If state is the same as starting state equals tuple banks. State equals starting state. And just print the number of steps we used. Is that it? 1610. So it takes about 1600 to get to this starting state, and then every 1610 it goes back in a loop. Makes sense. Correct. You code professionally? Yeah, I am. That's pretty much every job I've had is programmer, software developer. That was after I researched in the field of theoretical computer science. It's just not worth as much money as coding. I mean, my most permanent job that I had while I was in the UK was at Amazon for Prime Video, but that was for a few years before I started just being a nomad and traveling around. Oh, it looks like Wugger's match is cancelled. So the match, As the Dreams match, has been moved to Saturday. All right. I thought you traveled because of your job. No. Well, in a way, I traveled because I hated being stuck in one place in my previous job, and that's why I traveled. Because being in London full stop is dreadful. I really don't like London. Hate it so much. Yeah, I could go on and on and on about why I hate London, but that would just take up the rest of the stream. So I need to copy that bit. I use AWS these days. Amazing set of tools, but a bit scary. I'm afraid they'll just turn off my account these days. Why do you think they'd turn off your account? Because of the nature of what you're doing, or because you're using too much processing power or something? I mean, in general, yeah, AWS is... Maybe they find something offensive I've said when I was a kid. Oh. What, AWS? But they're not a social media company, so I don't think... I've never heard of anything like that with AWS. Like, maybe with stuff like social media companies like Twitch or something, maybe they might do that, but AWS, I don't think you have anything to worry about. Didn't they ban Parler? I don't know. What's that story about? From using AWS as a tool? Back in 2021, Parler had to rebuild from... Wait, Parler is a company, not an individual. That's not unusual for companies to ban other companies from using their software, but it's a whole different story if it's an individual. I wouldn't worry about it. So if I build my company... Oh, you're talking about building a company on AWS. Well, I don't know. What was the reason Parler were banned? Was it actually because of something offensive they said when they were a kid? Or was it something offensive they said while they're an adult? Because that's also a different story, isn't it? Like, no one really cares what you said as a kid, I would imagine. I've never heard of that being a problem. But if they've tweeted stuff in modern times, and AWS didn't like it, then that wouldn't surprise me. That's not unusual. But it wouldn't worry me because in a lot of these cases, when I hear about these things, when I look at what they actually tweeted, what they actually said, I'm like, yeah, that was actually pretty offensive, so... Pretty Orwellian. Well... I wouldn't use the word Orwellian if it's a private company and not the government. But, okay, you could argue that AWS is so powerful that, you know, all the companies, even Google, are running on AWS. So, yeah, I suppose you may have a point, but... Still, though, if I were to make a judgment, I would have to actually see what was said. And if it was something that was actually offensive or harmful or... I don't know, like racist, or that would lead to people getting harmed or inciting violence or anything like that, I would be like, yeah, sure, they should be banned. But But I can't make a judgment unless I've actually seen it. Because it's actually harmful to AWS if people start using it that way, right? So that they kind of, any lawyer will tell them they pretty much have to ban people who are using that way, because if they don't, then people will point to AWS and say, you were the person who provided the tools, you share part of the blame. And sometimes that's actually, they can actually legally be sued for that kind of thing. I mean, you get, all the big companies are facing government scrutiny right now. Facebook, all these companies, for, you know, having provided their tools to certain people, and not taken enough care in, you know, banning Facebook people on Facebook who were promoting certain things and so on. So they kind of, under the legal system, they kind of have to ban them. There's no way around that. Otherwise, they become responsible for what those people do. So, all right, well, where am I? Oh, I didn't paste this in. Parler is the social media where Trump went after he got banned. Oh, that's Parler? Okay, well, I mean, my personal opinion then is I'm quite happy that AWS banned them, but Section 230 is supposed to protect them. What's Section 230? Like, if it's a private company, surely they can ban whoever they want for any reason they want. Like, what? I don't know that much about American. It's US law to immunize AWS from user content. Well, you say supposed to, but it also won't protect them from public outrage, and that's also very damaging to them. But I don't know how strong Section 230 is, so I don't know anything about that. But I mean, even if that, I mean, companies like YouTube and stuff are getting in trouble for what their users are doing, right? So I imagine it's not black and white Section 230. I imagine it's still, you're always at risk, and you always have to argue your case, and there's always a risk you might be held accountable, because, I mean, this is happening to Facebook and Twitter, I guess, all these companies, isn't it? So they probably still have to spend a fortune in these legal cases when they come up, just to argue their case, and defend themselves under Section 230. So it's still a financial loss. $3,156. That is correct. All right. Next part. Right, we're expecting 1610. Yep. ChatGPT wins again. I mean, even ChatGPT is getting in trouble for stuff that people are using it for, so they're having to tread very carefully. What am I doing now? You'll beat GPT when the 2023 one drops. We'll see. Yeah. I'm not so sure, though. I mean, people were doing it in 2022, you know, for fresh problems that ChatGPT has never seen before, and they were winning. They were getting to the top of the leaderboard in seconds, like they were completing it. So I'm not so sure. I think ChatGPT will still dominate. But I won't do it because I don't want to. Oh yeah, no, I can do it after I've solved it myself. That's fine. Yeah. Do you think all the GPT solutions can be found in GitHub? What do you mean by GPT solutions? The solutions that people have come up with are definitely available on GitHub. So that's definitely very possible, and there's one flaw in this study that I'm doing, because not only that, but people have actually asked ChatGPT about this in the past, and it's written code for them before, and I've found evidence that it doesn't have internet access. But that's internet access, isn't it? That's if it's been trained on Reddit, GitHub, and stuff, that is what we're talking about, isn't it? If it has access to documents on GitHub, then it would have access to those solutions. Nothing after 2021. Well, they say that, but they might have started training it on stuff on 2021. I think they're only saying that because it's not complete, so they don't want people to expect it to have knowledge. But I've definitely found proof that it knew stuff, but it was probably because people asked those same questions to ChatGPT in the past. But there were problems that I asked in Advent of Code, and it came up with a numerical answer without me even telling it what part 2 was. And it would give me the answer for part 2 without me asking it. And that was proof that at least recently people have asked it those questions and it's remembering those answers. So it's not proof that it's using GitHub necessarily, but it is proof at the very least that it's remembering recent stuff and using it in its model. With GitHub, I guess we can't really prove it unless we find something that's only in GitHub. But I mean, I would expect they have started training it on recent years because that's their goal, right? They want it to be up to date. But I think they're just saying that they're not offering any promises for anything after 2021. Because companies are already building products on ChatGPT, so I think they have to say that because they don't want them to actually expect to have recent memory access. So that's 5. On day 7. Okay. Recursive circus. Also, I mean, these years that I'm doing are before 2021 anyway, so they've probably been around for a long time. Yeah, I mean, he can't just Google search for it in real time like Alexa or whatever. Well, I think it's mostly irrelevant because okay, no, he can't do that probably. It would be too expensive for him to do that because then he'd be making API calls to Google, which would be an expensive operation and take too long. But if ChatGPT has recently archived stuff from Google search and stuff like that quite recently, then it's equivalent to having done a Google search, I guess. So there's no real limit on how recent something can be before ChatGPT doesn't know it. It could know anything recent. It's just a question of when it trained on it. Cursive circus. All right, this one looks like it might be more interesting. Wandering further through the circuits of the computer, you come upon a tower of programs that have gotten themselves into a bit of trouble. A cursive algorithm that's gotten out of hand. And now they're balanced precariously in a large tower. A large tower, you say? One program at the bottom supports the entire tower. It's holding a large disk, and on the disk are balanced several more sub-towers. Okay. At the bottom of these sub-towers, standing on the bottom disk, are other programs, each holding their own disk, and so on. At the very tops of these sub-towers, many programs stand simply keeping the disk below them balanced, but with no disk of their own. Okay. It's a bit confusing. Alright, you offer to help, but first you need to understand the structure of these towers. You'd ask each program to yell out their name, their weight, and if they're holding a disk, the names of the programs immediately above them balancing on that disk. So every program... So every program holds a disk. And on that disk... Oh, they might not be holding a disk. They may be holding nothing, or they may be holding a disk. And on that disk may be other programs. And then the rule applies to them too. Okay, fine. That makes more sense now. You write this information down. Unfortunately, in their panic, they don't do this in an orderly fashion. By the time you're done, you're not sure which program gave which information. But they do say their name. That's the important thing. Okay, yeah. You're not sure which program gave which information. But you are, because you know their name. So if they gave you their name, then you know which program gave you which information. Why does it say you're not sure? Okay, let's have a look at the example. So these guys have said their weight and the names of programs on that disk that they're holding. Okay. Then you'll be able to recreate the structure of the towers that looks like this. Okay, fine. In this example, TK is at the bottom of the tower. You need to make sure your information is correct. What is the name of the bottom program? Fine. This is a tree problem. I just don't understand this line. You're not sure which program gave you which information. That doesn't look that doesn't look correct to me. You do know. They just said their name, so you do know. I'm not sure what they meant by that. Anyway. So this is really a you build the tree and then you just kind of go backwards through the tree until you get to the root, essentially. You want to find the one node which doesn't have anything pointing to it. Alright, let's start coding. We don't even really need to build a tree, we just need to say, if this guy is pointing to these guys, then these guys have parents. So we put their parent boolean to true. We just need to find the one guy who has a parent boolean of false. We don't actually need to build the tree data structure. We might need to for part 2. We'll see. Okay, so this is a nice looking problem, I would say. I like trees. They're mathematically elegant. We don't want to put it there. Put it there. Okay, so needs a bit of parsing. The weight, we don't need that right now. Do I like hexes? Yes, I do like hexes. Like in video games or board games that use hexagonal grids, I think they're quite cool, and I prefer them to square grids. Like when Civilization 5 came out, I thought that was I loved Civilization 4, but I thought changing from a square grid to a hexagonal grid was an awesome change. And it got away with the issue where diagonal movement was treated as the same distance as horizontal or vertical movement in Civ 4, which is a weird thing because it's not topologically, doesn't make sense, but it's the only way to make the board game work. The other day I was playing Etrian Odyssey and got into a battle with Hex Frog plus Tree Frog. Wait, this is a single player, or were you talking about multiplayer and you were playing against people who had those usernames, or what? I don't know anything about this game. Etrian Odyssey. Etrian Odyssey, let's have a look. Oh, okay, so it's like the monsters were called Hex Frog and Tree Frog. Cool. Maybe I'll have to play it then. Just so I can find the hex tree. Is it turn-based? Because I really like turn-based games these days. Okay, that's cool. I'll have to play the Discworld games at some point because that's the origin of my name. Hex, the computer from the Discworld series. Alright, so... yes, play them. I've heard the point and click adventures are quite brutal though. I've played brutal point-and-click adventures before. Simon the Sorcerer. I feel like I've heard of that. Let's have a look. Simon the Sorcerer. Simon's not a very sorcery name, is it? Oh wow, it does look a lot like Discworld. I mean, he's a wizard, I guess, so... Cool. Oh, it was heavily inspired by Discworld. Makes sense. Oh, this company originally wanted to make a Discworld game, but they couldn't get the license for it, so they made this. Interesting. Alright, so... for line in f dot read lines. So we don't need to do much with this, we just need to look at the right-hand side only. We don't even care about the left-hand side. Oh no, we do. Because we want to put these names into the... So the full set... Okay, I get this. Alright, so we want to tokenize this first. So tokens equals line.split. So we want programs equals just an empty set. So programs.add tokens, the first token. So this alone will give us the full list of programs because every program speaks. Now for every program on the right, we set a boolean. We say or we just say child programs equals set. So we want to say that's 1 token, 2 token, 3 token, so the 4th onwards. But then there's the comma. Well, we can remove the comma, I guess. So the 4th token onwards. Okay. If length, or just say for token in tokens 4 onwards, child programs dot add token dot replace the comma with empty character. It's 3, not 4. 0, 1, 2, 3. Alright. So after this is done, if we do programs minus child programs, we're left with the one program who is not a child, i.e. the one holding it all up. So print list programs minus, is it minus? Set difference. Just take the one element from there. It's Vitesse. Good old Vitesse. So we didn't have to build a tree yet. Correct. Okay, what now? Okay, big description here. The programs explain the situation. They can't get down. Rather, they could get down if they weren't expending all of their energy trying to keep the tower balanced. Apparently, one program has the wrong weight, and until it's fixed, they're stuck here. For any program holding a disk, each program standing on that disk forms a sub-tower. Each of those sub-towers are supposed to be the same weight, or the disk itself isn't balanced. The weight of a tower is the sum of the weights of the programs in that tower. Right, okay. In the example above, this means that for UGML's disk to be balanced, Gixo, Ebi, and Juputl must all have the same weight, and they do 61. Okay. For TK and K to be balanced, alright, so in this case, TK and K's children are not all the same weight. Ugumul has 251. Given that exactly one program is the wrong weight, what would its weight need to be to balance the entire tower? Oh my god. Okay, we can recursively calculate the weights using memoization applied to the root. So, okay, I can sort of see how to do this. So, so the root is this. We found the root, the guy who's holding everything up. Alright, so now we want basically weight equals that. It's going to be a table which maps every program to the cumulative weight of themselves and everything they're carrying. Okay. And this can be calculated by okay, first things first, we need to record the program weight for each guy. So program weight of tokens 0 equals int of tokens 1, but we need to skip the bracket characters. Let me try printing this. I just want to see what it looks like. $2158 DIHV. That's correct. Okay, so we know what individual programs weigh. Define get weight of program. We need to record their children as well. So, child's equals dictionary. Child's the token in tokens 3, blah, 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 child programs dot add. So child equals that. Put the child in the child programs and temp child's dot append child, and then we want to say child's tokens 0 equals temp child's. So we've recorded a bunch of properties: the child's, the weight, the names of all the programs, and that we don't really use except for part 1. Okay. So we've got get weight program. So given a program, how do we compute its weight? We say W equals the raw weight, no, the program weight of that program. We add on the weights of its children. So for child in child's program, W plus equal get weight child. We don't really need memorization here, because if we go top down, starting from the root, we won't actually call things twice, it will just work. So W plus equal get weight child. And then we put it into the table. So the weight of this program is W. Return W. We could get an out of recursion, hit the recursion limit. But how many are we dealing with here? 1,000. So the depth is going to be less than 1,000 probably. So we're probably fine. So now we just call get weight on the root. We just print it as well so we know what it looks like, how heavy the whole tree is. Oh, don't need that anymore. That's how heavy everything is. Okay. Now, what we're trying to do is for program in programs, we're checking if all its children weigh the same. I mean, if one is different, oh, it's not quite this simple because we need to go once we. Okay, so have a think about this. So we're trying to find the highest point. So we're trying to find a program who is carrying a set of children. One of them is the wrong weight. But if we check that wrong weight child, that child is carrying balanced children himself. That would indicate that the problem lies in his innate weight and not in something further up the chain. So trying to find the highest point. So yeah, that's not hard to calculate. So we're trying to find, let's try and express this in code. For every program in programs, we want to check A, are you carrying an unbalanced set of weights? And that would mean the weights of your children are two. There are at least two or more. There are actually, it's exactly two different weights. Okay, so if the set of weight child for child in a child's program, if the length of that set is 2, that means we've got two different weights. All right. Now there's a slight issue. What if there were three different children, and one of them had the wrong weight, we'd know that one's the wrong one. But if there's two children and they have different weights, we don't actually know which one is which. We don't know which one's wrong. I think that's unsolvable in that case, so we can just assume they don't give us that case, because how could you know? So we'll just have to assume that if this comes up, there's going to be at least 3. Because you wouldn't know which one's wrong, and even if you go up the children from those points onwards, you still wouldn't know which one's wrong. Okay. That's a bit weird though, but... Okay, so we'll assume that there's 3 or more, okay. All right. What are we doing at this point? So we're trying to find. Okay, we're trying to find which one's the wrong child. Which one child is the wrong weight. So there's two different weights. We need to find. I guess we have to find the most common. Child weights equals this, basically. The weight of the child for child in child's program. The length of the set. That is to we say is there a quick Python method for finding the most common modal value? Find the modal value. No, you just have to count the frequencies. I thought there might be a statistical method or something. Okay, let's do this. This is a good method. Let's say modal. No, we don't want the modal. We want the least frequent. What's the opposite of modal? Least frequent equals, so we want the min amongst the child weights. Key is child weights.count. All right. For a child in child's program, if weight child is the wrong weight, then this is the child we're looking at. Now we want to check that this child, although his total weight is wrong, the children he's carrying are actually balanced. That would mean that his weight is wrong. So if he's got the wrong weight, total weight, now we want to check if grandchild for grandchild in child's of the child, if length set of grandchild is strictly less than 2, that means this child has the wrong weight. What is the correct weight? We have to work it out from here. So we have to say, so the least frequent was that. So the most frequent was the other way around. Most frequent is max. of the child weights. The diff equals most frequent minus the least frequent. That is the number you need to alter by to get to the correct weight. So then we print the program weight of this child plus the diff. That's what his correct weight will be. And break out of this loop, but it will still execute the rest of the loop, but that's fine. Right, will that work? Seems a bit of a mess. 910? And we only got one print here. That's a good sign. That means there was only one unique situation found that matched this, which is exactly what we're looking for. Phew! That's correct. Oh man, that loop at the end there was a bit of a mouthful. But I think that's what you got to do, really. Now, yeah, the problem would be unsolvable if there were two, because you wouldn't know which was correct. It didn't actually say anything about that, but I guess... you just have to assume it's solvable. Okay. Okay, ChatGPT, let's do this. ChatGPT might struggle on this one. That was pretty complex logic. But I've said that before, haven't I? And he always surprises me. The first program is probably fine. So he's actually building the tree fully. I didn't do that. I just quoted a boolean. Okay. List object has no attribute split. What? P.strip for P in parts 3.split. What's parts? Parts is line.split. Yeah, what? Dot split. Whoa, he's made an actual syntax bug here, hasn't he? So line.split is a list. He's taking a list, doing dot split. That's weird. Yes. You should be sorry, ChatGPT. Vitze is correct. Okay. We'll let you off. Alright, problem 2. This is the hard bit. So he's made it all nice and functional, which is not what I did. That's pretty nice looking code. Is it correct though? I mean, it looks pretty good. He's got the max and the min. The different, yeah. This is. I've been bested. Oh, for fuck's sake, he's not given the... Hang on, let me just tell him. Please give me the full program, not just new methods. He's just given me a bunch of methods, but not the full program. There we go. Because he didn't include the methods from the previous program. I should say full program from now on. I'll just wait for him to give me that. Four, 5, 7, 7, 4. That sounds way off. What was it supposed to be? It's supposed to be 9, 10. Fine. Calculate correct weights. We'll just change that one method. What does he actually change there? He's added this line here. Unbalanced program weight equals... Okay, fine. Still wrong. Should be 9, 10. Okay. Not sure. It looks a bit dubious. What is going on here? Problem is in the... Oh, yeah, no, that seems better, because you do need to find the highest point. Nope. Okay, yeah, that is indeed what you need to find if you weren't doing that already. Alright, I'm giving you one last chance, ChatGPT. It was still wrong. Last chance. I need to be stricter on these because I think last time I was doing this I was giving him loads of chances and it just spending a lot of time. I should only really give him like 5 chances or something like that. God, that's getting bigger and bigger, but... 173. It's too low now. Alright, that's a fail. Right then. So that's 2 to me. Alright, what now? Should I carry on or... So it's been 3 hours. I think that's a good place to leave it for now. So that's problems 1 to 7. Yeah, pretty good pace within 3 hours. Towards the end of the advent calendar, it's probably going to be like 2 hours per problem, so... I should enjoy the pace while I can. See, I'll probably come back probably the day after tomorrow, or if I'm just really in the mood, maybe tomorrow. But I usually try to do every second day. Oh, and the other thing is, oh, I could also have a look at the stats. So 1, 2, 3, 4, 5, 6, 7. Okay, so that's roughly a measure of difficulty, but it's a bit biased because some people quit after a while. Not just because it's difficult, maybe they just get bored. So, but it's a rough. If you see little blips that go to the right or the left, that's usually because that was a bit more difficult, a bit easier that particular day. For example, 21 was probably a difficult one, but the times, I don't know, we can just look at the one we did, which was 7. Wait, how do we... People solved it in... I mean, the part 1 was pretty... Oh, that's both stars in 9 minutes 36. Yeah, I mean... That's pretty good. I couldn't do it in 9 minutes 36, even now that I know what my algorithm is. But that's one of the properties of recursion. You can usually write really nice compact code that sort of works. 1 minute 44 for part 1. Yeah, that's believable, yeah. And the other thing is I have a leaderboard which anyone is welcome to join. How do I get to it? Private leaderboard. View. Well, these are 2 viewers who joined my leaderboard, so yeah. So anyone who's on Advent of Code can just use this code here. Well, I mean, I'm going to be uploading to this to YouTube with the code, but I can also just paste it here in case anyone actually wants it. But yeah, that lets people kind of participate in this. This one was one that I did, but Ria is missing in action. I don't think she streams anymore, but I was part of her leaderboard back when I joined this Advent of Code. But yeah, so if anyone doesn't know what Advent of Code is, that's basically a summary of what you do. The whole thing was written by one guy called Eric Wastel. He actually stopped by my chat once, and he was watching me solve one of his problems, so he is active on Twitch, and he does watch people streaming Advent of Code every now and then. It seems like this is building some sort of breadboard with a circuitry. Okay. Oh, we should say goodbye to ChatGPT for now. All right. Thanks everyone for watching. See you next time for day 8 onwards.